so there's a who doesn't believe in God. Okay, little. So here we have get char, and then read. This reads the cycle in gigahertz, or it's a 3 gigahertz timer that matches the cycle. Somebody said God doesn't exist. I beg to disagree. This will prove God exists. So, random words based on timer values. Do you see the timer values over here? That is definitely not human. Okay, anyway. So this guy, there's an article on debug memory corruption. Who the hell writes 2 to my stack? Okay, where do I begin? First of all, paging is not used. That's the first confusion. So if I say mem BIOS rep, this is the BIOS memory map of physical memory. Okay, now let's think about this a second. If it's identity mapped so that paging is basically not used, then that means the physical memory is the same as the virtual memory, okay? Now let's just do a little thought experiment. If we have 2 tasks and we put one of them with the stack at, if one task has the stack at, oops, damn it. Let's do a thought experiment. If one task has the stack at 7FFFFF8, then what happens if you have another task with the same address? It's not a good idea to have 2 tasks with the same stack, obviously. Obviously, that's not a good idea. So if you don't have paging, then that means you put your stacks in different places. Okay, to begin with, I don't use this area at all for my stack. Your stack is likely to be, well, let's see where it is right now. FSRSP. The stack is in the region up here. So the stack is up here. Okay, let's look at another task. Here's a task. So the one task had the stack here. Damn it. I'm gonna hit Control-Shift-W. Control-Shift-W. Okay. So one task has a stack here. Now let's see where this guy's stack is. FS is the task record. God, I hate that bird. I like the bird that died. I don't like this bird. This bird, I hate this bird. You bird. Bird. I don't like that bird. Okay, so the system does a malloc for the stack. And so the stack is not at any particular location. Now, as a matter of fact, the stack does not grow. The stack does not grow. So what that means is if you basically if you do recursion, you can crash it. If you go deep recursion will crash it. some oops, damn it. Okay, start over. Fuck. Oh, fucking. Okay, I-64, some I-64 in. Okay. If not in, return 0. Else, oh, it's okay. When you're at the command line, you cannot do it that way. The shut up. Just listen. It's ugly. Get the job done. Okay. So let's say sum 5. You son of oh, you idiot. Let's start over. In plus some, okay, sum 5. 15, so that's 5 plus sum 3. 6, okay. You see what it's doing. Okay, so unassemble function sum. Okay, so it's using the local variable for n. It's loading n into a local variable, testing it, return XOR 0, jump to the end, -1, push call. Okay, so I solemnly assure you, let's see, the stack is at, I think we have 128. Oh, okay, so let's see here. So the stack base is 44C28. The stack pointer goes down. So how much can we go down? We can go down 40000. That's 4 times 64. So we should be able to go down 4 times 64. If we divide by 8, it's 32,000. Are we? How much are we loading? How much on the stack? We are using. We're using 8 on the stack. Okay, so we should be able to do 32,000. So if we say sum 32, let's say 31,000. Crash and burn. Oh, that was dumb. I don't know why that was dumb, but that was dumb. What? How much stack are we using? We're using, oh, the return address and the parameter. So I crashed it. Okay. That was dumb. Okay, so long story short, the stack will. So if you exceeded the stack, if you overflowed the stack, then it could probably get written to. So that's no surprise. So the first lesson is 7FFF is not the stack. It could be, but it's probably not. The second lesson is This is a ring 0 only operating system. That's because cheap thrills are what we're all about, okay? We want to provide the experience of hacking the kernel and hacking everything, so everything is wide open. You can access any memory at any time. And so this guy was talking about writing to the stack. First, he probably was confused where the stack was. Second, he didn't realize it's a ring 0 operating system, so everything is permitted. Third, he might not have known that the stack can overflow. Fourth, I just changed the arguments for a few. He could have been talking about the new functions. Just today I changed. God, I hate that bird. I changed the arguments to these functions. It could crash an existing application. I don't care. Anyway, so I don't know. I get these people. So he's talking about throwing an exception in a kernel routine with asynchronous. My I/O is not asynchronous, probably. There is a throw, but it's different from what you're used to. You put an 8-digit whatever, you put a character constant. Okay, so if you look at put chars, instead of, I thought, why should we just throw one? Why should we just print one character? Why don't we print up to 8 characters with put char? Okay, so now we have a 64-bit value for little words. And the throw, I wrote my own compiler, and throw operates differently to what you're used to. What am I talking about? Well, throw puts a value into the task. You remember how we're accessing FS? Okay. Exception CH. When you do a throw, it copies that into exception CH. And then it unwinds and it calls your exception handler. In your exception handler, you need to check FSCH, and that's the way the throw works. So you don't have to declare an exception class. You just have you can put any 64-bit number in here, and then it's available to you. You could put a pointer if you wanted to pass a pointer to a structure. You could throw a pointer, and then it would be a pointer. So they're really. The nice thing is we don't have error no. We have something a lot better. Like when I do a directory, it tells me how many files, 23 files. The return value is a function. Okay, so it called a function. If I do find file start /star text, there are 364 files that it found. Okay, so the return value of a function is not error no. So so instead of okay, so the operating system is small. The operating system is small, and as a matter of fact, these are all the exceptions that can be thrown. Okay, so you can actually find all the exceptions in the operating system. Those are all the exceptions there are. Okay, so it's a really simple technique. If you're curious how I do a throw, we can go into the exceptions. This is the throw function. It's an actual function. It's not. So what does it do? I told you. Didn't I tell you that? I told you it does this. So it stashes the caller. That it gets that climbing the stack, gets the base pointer, and if you don't want to catch an exception, when you catch an exception, you set catch exception to true. God, I hate that bird. I'm gonna fucking kill that bird. The bird I like died. This bird I don't like. So anyway, if it calls, here's where it calls the handler for the current function, and if it catches it, then it takes it. Otherwise, it climbs the handler list. Every time you enter a function with a try catch, every time you enter a function with a try catch, this is what happens when it calls the try. The try creates a node on your task with, this is for unwinding. So you remember the FS is your task record. This is like PID except it's task record. So there's the task record has a list of each time you go deeper and deeper into exception handlers, each time you do that, it allocates a new exception handler on the heap. It allocates it on the heap. Okay, so anyway, I don't know how everybody else does exceptions, but that's the way I do them. So let's see about. So he's probably all confused. I get these people cocky sons of. I don't even know if that's about me. So he's probably all confused. I get these people cocky. I don't even know if that's about me. So he's probably all confused. I get these people cocky. Shut up, bird! Okay, so somebody said the exception value gets clobbered. Now let's just think about this. We have a function here, and we're throwing an exception. Why would there be a problem with this value getting clobbered? That means that if you're inside, so if somebody catches it, then it's up to them. So you can throw another exception if you have a. If I throw an exception in here, we got an exception. Got an exception. If I put a handler, Now if I don't handle it, it got elevated. Now if I do handle it, FS you know, I used to have it so you could resume execution, but I got rid of that. I used to have an ignore. So what we can do is, let's do this. Okay. So we're catching it and no problem. So why are you worried about it getting overwritten? Now if you do throw in here, oh, you know, we f***ed it up. I caught it and I threw it. You know, I didn't really test this, to be quite honest. I think we don't want that. Damn it. Don't do that. The moral of the story is, there's a man goes to a doctor. He says, when I raise my arm, it hurts. The doctor says, don't do that. Okay. I don't care. So the exceptions are adequate for... They're adequate for my purposes. I don't care. If you're doing something crazy, don't do that. Goes to the doctor. When I raise my arm, it hurts. Don't do that. I don't care. If you're doing something crazy, don't do that. Goes to the doctor. When I raise my arm, it hurts. Don't do that. I don't care. If you're doing something crazy, don't do that. Goes to the doctor. Okay.